Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded from Module 1 to Module 3 of the subject. If you want to check it out, please do check out in my channel. All the videos are available. Now in Module 4, I have done already the time response analysis of first order and second order systems. In this video, I will do a new topic related to the time response analysis. I've already done the introduction, time response of first order system, second order system. In this video, I'm going to do the time response specifications of second order systems, which completes the first chapter of the module 4. Control systems are generally designed with damping less than 1. Usually with damping less than 1, the control systems are usually designed. That is oscillatory step response. Okay, high order control systems usually have a pair of complex conjugate poles with damping less than 1 which dominate over the other poles. Therefore, the time response of second and higher order control systems to a step input is generally damped oscillatory nature as shown in the figure. This is the damped oscillatory nature. How the, if you see here, peak, overshoot, allowable tolerance, like that, the damped damped oscillatory nature is called according to this figure, the higher order and second order. Okay, from figure 4.11 it can be observed that the step response has a number of overshoots and undershoots with respect to final steady state value. There are some overshoots, that is at high and low. Since the overshoots and undershoots decay exponentially, as you can see they are decaying exponentially, the peak overshoot is the first overshoot and is same as the peak of the complete time response. It is the peak of the complete time response. There are some transient response specifications. Transient response means changing. The response goes on changes, right? The transient response specifications, there are some response specifications. We will see one by one. Delay time TD. That delay time is the time required for the response to 50% of the final value the very first time. The delay time is nothing but reaching the 50%. If you do into 100, it is nothing but 50, right? So 50% of the final value if you are reaching, this is called the delay time. Rise time TR is nothing but the rise time is the time required for the response to rise from 0 to 100%. If you see, this is the 100%. How much time it is required to reach from 0 to 100% of the final value for underdamped systems from 10 to 90%. 10 to 90% for the overdamped. Okay, here it is shown for 0 to 100%. For overdamped it is for 10 to 90%. Peak time. The peak time is the time required for the response to reach first peak of the overshoot. This is the first peak of the overshoot, MP. This is known as peak time. Okay. You need to know this time response specifications. They'll ask in exam, write the time response specifications. Next, we have peak overshoot, MP. The peak or maximum overshoot is the maximum peak value of the response curve measured from unity. If the final steady state value of the response differs from unity, then it is common to use the maximum percent overshoot. It is defined by, this is important, maximum percent overshoot is nothing but C of TP, nothing but peak overshoot minus C of infinity, final value by final value, that into 100 you will get maximum percent of overshoot in the second order system. The amount of maximum percent overshoot directly indicates the relative stability of the system. Okay, it is directly indicating. If there is a more maximum overshoot, then stability is more. Like that, the amount of maximum percent overshoot will relate to the stability. Then you have settling time TS. The settling time is the time required for the response curve to reach and stay within a particular tolerance band, usually 2 or 5% of its final value. The settling time is the time required for the response curve to reach and stay with a particular tolerance. If you see, this is the tolerance. this is the value, this is the value, the middle whatever is there, this is a particular tolerance. This is nothing but settling time. Okay, usually it will be 2 or 5% of its final value. Steady state error ESS. What it means is, it indicates the error between actual output and the desired output as t tends to infinity. Limit t tends to infinity, output by input, nothing but output by desired input, R of t by C of t. Okay, input minus R of t minus C of t. For example, if you see here, this is output and this is input. So this, if you do differentiation, so if you do difference of this and tends to infinity, you will get the steady state error. From figure 4.11, it is seen that by specifying TD, TR, TP, MP, TS and ESS, the shape of the unit step time responsive curve is virtually fixed. If you see, it is virtually fixed. In most cases, it is desirable that the transient response be sufficiently fast and be sufficiently damped. Okay. Thus, for a desired transient response, the damping ratio must be between 0.4 and 0.8. It should be damped. For larger values, the system responds very slowly. So, it should be between 0.4 and 0.8. So, it is desirable transient response. If it is more than 0.8, if xi is more than 0.8, the system sluggishly means slowly. Okay. So, in time response specifications of second order system, you should just know the specifications of the second order system. Those all points, 6 points with the graph, you should explain. This completes the time response specifications of the second order system. After this, I'll do one more video which are related to the sums related to these topics, separate video. So, it will be easy for you to understand all the problems in one video. So, till here I stop this video. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.